Hi there and welcome to another video from HEGARTYMATHS, a Core 4 Maths A-Level video on vectors. So this is our first video on vectors. As always, check out YouTube, Twitter or Google Plus for more help with your maths studies. So in this tutorial, it's the first one on vectors, it's chapter 5 in the Edexcel Core 4 syllabus. And just to take a look at the syllabus, here's what we need to learn about vectors. There are quite a significant number of things we need to learn about vectors, but today we're just going to really focus on an introduction to these. So we're not really going to touch on many of these apart from what the magnitude of a vector is. Okay, and we're going to generally talk about vectors leading into these type of ideas. Right, so this video I'm going to go through some very basic definition of vectors. It's very important you write these down, and it's very important you take the time to draw the pictures and understand that having a firm understanding of the basics helps everything later on in this section of the course. Okay, so to start with, an introduction. Here's our first definition we need to be aware of. We need to know what is a scalar, and a scalar quantity is a number that has magnitude or size. Magnitude and size mean the same thing. So it's just a number that tells you how much of something there is. Simple as that. Okay, a scalar quantity. Now, for example, let's write a few down. For example, let's say 20 kilometers per hour. That's a speed. We are going at 20 kilometers every hour. That's just a magnitude or size. Or another one could be something like 76 meters. Again, it's 76 of meters. So it's a scalar quantity. It just has a size. 20 kilometers every hour is its size, and 76 meters is its size here. Now a vector is taking a scalar one step further. Here's the second definition. A vector is a quantity that has both magnitude or size, so we're going to have a number describing how much of something we have, but also that number has a direction associated with it. Okay, so that's very important. So here, let's use these examples. How could we make this a vector? Well, its magnitude could be 20 kilometers per hour, and its direction could be due north. And now it's got size and direction, and so it is a vector. Okay, how could we make 76 meters? Well, 76 meters would be the magnitude, and we could say, I don't know, on a bearing of 060 degrees. Okay, so that's telling me in what way to go. So just to make this clear, this at the moment is just a number, and this is just a number. However, when we give it a direction as well, 20 kilometers per hour due north, we can actually draw a picture of that. What we're saying is we're going 20 kilometers per hour, but we're going in that direction there. Okay, and similarly with this, we're going 76 meters on a bearing of 0600. Well, if that's north here, 0600 is something like that. 060, sorry, that's 060. Okay, so we are going on this bearing and we're going 76 meters. So we're going 76 meters with a direction associated. Okay, so that is what a vector and a scalar are, and you need to know the difference between the two. Okay, next, notation is very, very important with vectors. So take your time to write this down and listen. Getting this right is the key to the whole topic. Right, firstly, say I'm at point P and I want to get to point Q. P is a point in space, Q is a point in space. They are usually with capitals, okay? And the vector that gets you from P to Q, we can draw as a straight line between them with an arrow on them. And we usually actually put the arrow here. Now, how do we describe getting from P to Q? Well, there are quite a few ways of doing it, but basically we say there are a couple of ways to do it, but here's the first one. We could write the vector as P, Q with an arrow over it. Okay, that is telling us that we are going from P to Q. From this one to this one. That's a way of writing it. And that is a notation for vectors. So we can write it like that. However, usually in this course, what we're going to do, to save ourselves writing down loads of positions in space, and this could get quite long, what we're going to do is we're going to call this vector from P to Q something. And we might call it something like A. Okay, so A is the same as PQ. Little a, like that. Now, in the books, this A will be a capital. But when we write it down, it's very difficult to show it being a capital. So what you do is you write a line underneath it, just to show it's a vector, as opposed to being some algebra or just a normal letter. So the vector from P to Q is also A with a line under it. In the book, you will see A as being bold. And one thing to bear in mind here as well, the direction we're going is very, very important. That arrow is telling us we're going from P to Q. We're not going backwards. We'll deal with going backwards later. So this is basically how you write vectors down. And make sure whenever you're dealing with vectors in a question, you draw them out and you label everything correctly. Here are endpoints, and usually we assign a letter, a small letter to that vector. Okay, the next definition, the modulus of a vector. Definition 3, the modulus of a vector is another name for its size or magnitude. So what I mean by that is, let's say we have a vector, let's say we're going again from P here to Q here. And we draw a picture, there's our arrow, actually draw it in the middle there, and we call that vector a little a. Now, the modulus of this vector is how long this is. How far is it along this line between P and Q? Now, the way we can write it, you need to know how to write it. PQ, that's how you write the vector P to Q. And its modulus, you write with a modulus sign around it. Okay? Or you do the exact same thing with the little vector A. You put a modulus around it. Okay, so that's how you write these, and the modulus is how long it is. Now all you'd have to do is, if you know how long that line is, say you knew that line there was 30 kilometers, then the modulus of this is 30 kilometers, and the modulus of this is 30 kilometers. It's telling you how far to walk from P to Q. You know the direction because it's along this line, but it's telling you basically when to stop. After you've gone 30, stop and you'll find yourself at Q. Okay, so that's the modulus. It's important you know these bit of notation here. Next, equality. When are two vectors equal? Well, say I've got a vector here. Actually, just say if I just take the same one here. Okay, say if I've got the following vector there, okay, and say I've copied it there. So I've copied the exact same one, but this is between point S and point R, let's say. Now, are these two vectors equal is the question. Well, yes, two vectors are equal, so they're equal, two vectors are equal if they have the same size or magnitude and the same direction. Now, although these vectors start and finish at different points, that doesn't mean they're not the same. They are the same because they're exactly the same length, okay? They are exactly the same length. The same length from P to Q is the same length as S to R, and they are going in the same direction. That is how vectors are equal. Vectors do not have to start and finish at the same point to be equal. So that's what equality is. Next thing, how do you add vectors? Say you were going from the point P to the point Q, maybe then to the point R. So PQ we might call vector A, and QR we might call vector B. Okay? And the question is, what does A plus B mean? What does A plus B mean? Well, what does A mean again? A takes you from P to Q. B takes you from Q to R. So we're going from P to Q and then from Q to R. That's the same thing, surely, as going straight from P to R. It has the same effect as going from P to R. So the same effect as going from P to R would be that vector there, which we can call A plus B. Okay? So when you add vectors, what you're actually doing, if you add vector A and B, the result of it is getting from your original starting point to the end starting point. Okay, so the vector A plus B, it can usually be shown like that, and it's called the triangle law. Okay, so when you're adding vectors together, the sum of the two vectors makes a triangle with the other two vectors. Negative vectors, next thing, quickly. So imagine we've got P to Q again. Here's our line here, and the direction is very important. So this vector here, PQ, is the same thing as A. Now the question is, what does negative A mean? Does that have any meaning at all? Well, negative A, we take that to mean going backwards, going in the opposite direction. So negative A means actually going from Q to P in that direction. Okay, so that's what a negative vector means. A negative vector just goes in the opposite direction to the positive vector, but it goes the same magnitude, obviously, but in the opposite direction. So that's what negative vectors are. And the last thing we need to really talk, one of the last things is subtracting vectors. How do you subtract a vector? So say you've got a vector, here, that's vector A, and say you've got another vector here, let's say that's vector B. And vector A is going along that way, and vector B is going along that way, right? Now clearly, let's just think about this here. Let's keep these vectors over to this side here. What do we think A plus B means? Well, that's quite easy, A plus B, right? A, actually, let's just group these together. That's A, and that's B. So when we add A plus B, we can just do that, and the resultant is there. Okay, so that is the vector A plus B here. Okay, so A plus B. Now what does A minus B mean? So I'm just going to rub this out for now. What does A minus B mean? Well, A minus B, we take that to mean, and we define this to mean, the A vector, and you add the negative B vector. That's what we take it to mean. So therefore, if this is our vector A and we want to work at A minus B, we add the negative B. Now that's B there, so we'll copy that. Now negative B, clearly, must be in that direction. So therefore A minus B is actually a triangle as well, but it goes like that. Okay, so when you subtract vectors, it's like adding the negative of the second vector. Okay, so that's what A minus B actually means. Right, vector diagrams, and then we'll do some examples quickly. Just to make sure you're familiar with these, here are some questions. How would you get from A to B? What vector would do that for you? Well, it would be little a. How would you get from B to C? Well, that's clearly little b. And how would you get from C to D? That's clearly little c. They're all easy. Next question. How would you get from A to C? Well, to get from A to C, you would go A plus B. How would you get from A to D, let's say? We go A plus B plus C. Okay? How would you get from, let's say, B to A? How would you get from B to A? Well, it's the opposite direction of A, so it's negative little a. How would you get from D to A? How would you get from D to A? Well, you'd go negative C, negative B, negative A. Negative C, negative B, negative A. Right? And, you know, it goes like this. You just have to be careful. Using vector diagrams, it's usually given to you, and you can get from any corner to any other corner going along the vectors or in the opposite direction. Okay, I think we've introduced everything. Now it's time for a few examples just to make sure we can do the questions. Always draw a picture when dealing with questions. A vector A is directed due east. Now, due east is that way. Okay, and that's vector A. And we're told the modulus of A is 12. So this means the length of this line is actually 12. Vector B is directed due south. So vector B is directed due south. Okay? So it's going down like that. And this is vector B. And its modulus is 5. So its length is 5. I'm going to rub that out for now. Okay? It then asks us find the modulus of A plus B. So before we try and find the modulus of A plus B, let's work out the vector A plus B. Now clearly the vector A plus B, if I take that and then I add that vector there, then the modulus, then A plus B must be this vector here. That must be the vector A plus B, clearly. Now, if you know the length of A is clearly 12 and the length of B is 5, and because this is due east and this is due south, there must be a right angle there, you could work out the length of A plus B. So the modulus of A plus B, we could work that out using Pythagoras' theorem. It must be 12 squared plus 5 squared square rooted. And when you do that, you get 13. So the modulus of A plus B, in this case, is 13. This one is 13 long. Without a picture, you wouldn't be able to do that. Next question. The diagram shows vectors A, B, and C. Draw another diagram to illustrate the addition A plus B plus C. Okay, so here are the vectors A, B, C. So we want to draw A plus B plus C. So here's A. Yeah, I'll draw it down here. Here's B. So we want to add A plus B, and then we get there. Actually, I'm going to make these over here just so they're not in the way. I'll draw it over here. There's A plus B, and then you want to add C. So you add C onto the end of it like that. So this line here is clearly A plus B plus C, and that diagram would illustrate it. Out of interest, what's that line there? Well, that line clearly is just A plus B. And that diagram illustrates for us everything we're asked. And the last example here, we're usually given a vector diagram, we're asked various things about it. In the diagram, Q to P is A, Q to R is B, Q to S is C, and R to T is D. Find in terms of A, B, C, and D the vector P to S. So how do you get from P to S? How do you get from P to S here? Well, what you do is you go P to Q plus Q to S. So you go P to Q plus Q to S. That's the easiest way in the picture. Now P to Q is negative A and Q to S is positive C or plus C. And we usually write that the other way around, C subtract A. Okay, and that's that done. R to P, how do you get from R to P? Well, if I was going from R to P, I'd go from R to Q, and then I'd go from Q to P. Now R to Q must be negative B, and Q to P must be positive A, and we usually write that the other way around, A subtract B. Okay, next one. How do we get from P to T? How do we get from P here to T? Okay, well, there are a few ways we could do this, but what we could do is we could just go P to Q along there, Q to R, and then R to T. P to Q would be negative A, Q to R would be plus B, and R to T would be plus D, and we'd usually probably write that as B plus D subtract A. And the last one, T to S, how would we get from T to S there? Well, what we could do, we could go, if we want to go from T to S, we could go T to R, and then we go R to Q, and we go Q to S. So T to R would be negative D, R to Q would be negative B, and Q to S would be plus C. And we'd probably just write that as C subtract B subtract D, and we're done. So that's everything in the first section on vectors. And just to finish off, make sure you read chapter 5, page 51 to 55, and do exercise 5A, questions 1 to 5. Thank you for watching.